Hello and welcome to this physical science lesson where we'll be talking about part of the electricity lesson, which is lesson 6. We're focusing on 6.3, electric current and basic electrical relationships. So quick review from electric current. There's three important parts to current that we're going to worry about, and it's going to be the voltage, also called electric potential, and this is the energy that's pushing the charges through the circuit. So you could have a circuit set up and electricity is not going to flow through it unless you have a voltage. So we're just going to use a battery to indicate voltage, but it could be a generator or a thermocouple or different types of batteries, lots of ways to start a voltage. So you need a voltage and a complete path that can conduct the electric current, in this case from one side of the battery to the other. We have current, which is the movement of electrons through a conductor, and again it requires a voltage to happen, and resistance. Resistance is how much the circuit tries to hold back the flow of current. So these three quantities are going to be really important when studying circuits. And the more stuff that you add to the circuit, the higher the resistance gets. So we could have things like light bulbs, we could have these little squiggly resistors. Those are all going to add to resistance. Some more about resistance. Resistance is measured in a unit called ohms and is written with this symbol, which is a Greek letter omega, this here. And there's different ways to change the resistance. So one way is just the amount of free electrons. So a material that has a lot of free electrons has less resistance than one that has few free electrons. Another way is the length of the material. As you make a wire or other conductor longer, it has greater resistance. Also, the thickness of the material. As you make a wire or other conductor thinner, it has greater resistance. And then temperature. As you make it hotter, it has greater resistance. And it's important to remember that you need a complete circuit in order to conduct electricity. So if you have, let me just bring that back. If you have a complete circuit, the electricity will be conducted. If you don't, if you lose any of it, it won't be. So if you, hold on. Okay, so right now it's a complete circuit, it's lit. If you lose any part of it, the light bulb goes out because it's not being lit. And it could be just a small break in the circuit anywhere throughout that whole path. If you have a break in the circuit, the current will not flow, and so the devices will not work. And that could be anywhere. If we had that break over here or over here, it would do the same thing. It would turn off the light bulb because no current would go through the circuit at all if there was a break anywhere. So that's just a quick review of that section so that we have a better understanding for the next thing, which is basic electrical relationships. And this is mostly going to be focusing on Ohm's law. So we have our three quantities that we're worried about: voltage, amps, and ohms. So we've kind of got a couple different ways to talk about each thing. So electric potential or voltage, remember that's the force pushing the electricity through the circuit. You can kind of think of that as the strength of the battery. The voltage is abbreviated V. Current is the amount of electricity going through the circuit, and it's measured in units called amperes, and that's abbreviated with an I. So I know that's weird, but it's consistently an I, just remember that. And then resistance is how much the circuit's trying to hold back the flow of electricity, and that's abbreviated, well, the unit is ohms, and it's abbreviated either R for resistance or with the omega symbol. And the relationship between these three is called Ohm's law, and it's expressed with this equation, which has three different versions. We use the one on the left if we're measuring current, the one on the right to figure out resistance, and the one in the middle for resistance, and the one on the right to figure out voltage. So here's a practice question with Ohm's law. Electric heater has a resistance of 50 ohms. If the applied voltage in a circuit containing the heater is 110 volts, how many amps of current are flowing through the heater? So we have our three things. We're given ohms, we're given volts, and it asks about amps. So we're going to use the version of the formula that starts with I equals because we're looking for current. That's what we're trying to find, and current is abbreviated with an I. So current equals voltage divided by resistance. So we just plug our two numbers in. Our voltage is 110, our resistance is 50, and we take 110 divided by 50 for our answer of 2.2 amps. Pretty simple. More Ohm's Law practice problems. Now we have a soldering iron with a 110 voltage. This current flowing through is 2 amps. What's the resistance? So now we use the other version of our formula, the one that starts with R. R equals, and it's voltage divided by current. So our voltage is 110, our current is 2. We divide and get 55 amps as the resistance. I'm sorry, this should be R. Sorry about that. R equals 55 ohms. Sorry, I copied and pasted the formula over and forgot to change it. Our next one, when a current of 0.2 amps, a resistance of 65 ohms, what is the voltage? So voltage equals current times resistance. Voltage equals 0.2 times 65 because our current was 0.2, our resistance is 65 for a final answer of 13 volts. And one more practice question. If the resistance of a circuit is 3 ohms, the voltage is 12 volts. What's the magnitude of the current? So current equals voltage divided by resistance. Current equals 12 divided by 3 because we had 12 volts, 3 ohms. And that means our answer is 4 amps. So it's really simple. You just got to remember which formula to use, which version of it. So again, if you're using amps, you're trying to find the current, you use this one on the left. If you're trying to find resistance, you use this one in the middle. If you're trying to find voltage, you use this one on the right. Now another formula is for electrical power. So this is watts. So if you look at light bulbs, they're given amount of watts. That's how much power they use. So electrical power is equal to voltage times current. So all you do is multiply the voltage times the current to find out how many watts it is. But when we talk about electricity, for example, the cost of electricity, it's measured in watt hours or kilowatt hours. So all you have to do is take the watts multiplied by the number of hours the device is being used to get watt hours. And then if you want kilowatt hours, there's 1,000 watts in a kilowatt. So you just take your watt hours divided by 1,000 to get kilowatt hours. So here's an example of that. We have an electric heater with 110 volts and 2.2 amps, and it's operated for 3 hours. How many kilowatt hours of electrical energy are used? So first, let's just find power. With our formula, power equals voltage times current. So 110 volts, 2.2 amps. We multiply that and get a power of 242 watts. Okay, so that's our power, and then it wants to know how many kilowatt hours are used during that period of time of 3 hours. So we have 242 watts, and it's running for 3 hours. So you just take 242 times 3 to find the number of watt hours. So watt hours is really just watts and hours. You just multiply watts times hours. And so we have 726 watt hours. But again, we usually use kilowatt hours when talking about selling electricity. So to find kilowatt hours, you just take your watt hours and divide by 1,000, and you get your final answer of 0.726. So yeah, this one is kind of a lot of steps, but they're pretty simple steps. We've just got our power formula, and then we just need to take our watts and figure out how many watt hours that is, and then convert that to kilowatt hours. And then it does also talk about some conversions. So we're talking about electrical energy, but often it's related to heat as well. Heat is also a type of energy, so it's also measured in similar units, BTUs, joules, and watt hours. So if we want to figure out how much energy is equivalent between watt hours and BTUs, our formula is watt hours divided by 0.293, and that tells us how many BTUs there is. So we got a practice problem for that. If 0.8 watt hours of electrical energy is lost as heat, how much energy in BTUs is produced? Okay, so we're just going from electricity to heat and figuring out how that converts. So 0.8 watt hours is our electrical energy, and we're just going to divide by 0.293. So 0.8 divided by 0.293 gives us 2.73 BTUs. So it's pretty simple. It's just a formula that you need to know. Watt hours divided by 0.293. Okay, so here's a practice question that's a little more real life, a little more something that you might want to figure out how much energy you're using. So how many kilowatt hours of energy would be used by a 40-watt bulb that runs for 10 hours every day during the course of 1 year? So let's start with what we know. We have a 40-watt bulb, so we don't have to figure out watts. We've already got watts. That's the power. It's running for 10 hours a day, so we could start with figuring out watt hours. So 10 hours a day, and there's 365 days in a year, so it's going to be 3,650 hours because we're talking about 1 year. So we're running this 40-watt bulb for 3,650 hours. So 3,650 hours times 40 watts gives us 146,000 watt hours. Remember, we just take watts times hours, and that gives us watt hours. So that is how much energy is used by that bulb. But there's one more step because we want to find kilowatt hours because that's what we use. So 146,000 divided by 1,000 gives us 146 kilowatt hours. That should be 6. So again, it's a few steps, but each one's pretty simple. So we have watts, we just need to figure out how many watt hours, and then just change that into kilowatt hours by dividing by 1,000. So that actually brings us to the end of this section. There is a lot more information in this section, so be sure to watch your other review video on your student portal, and read everything and ask questions if you have them. But this is all the practice questions that we were going to go over. So if you have any questions, don't hesitate to contact your instructor.